Hello, we are back to Studio One, and now I'm on the opposite side of the table as a host. And today with me I have Viktor, my friend from Kafka. And hello, Viktor, how are you doing?
Hello, Anton. It's great to be here. Welcome to live stream. As a reminder, all events occur in real time, as events occur in Kafka, and all events also occur in live.
So one question to you all. How much do you know about Kafka? Or are you like me, think of Kafka as just a messaging middleware, sending messages from one point to the other point?
You are lying, my friend, because we spend so much time, or I spend so much time with you. We're doing some of the talks together and explaining Kafka to
just
people.
Keeping the expectations low.
We're trying to do this like engagement farming going. So please engage with us, ask your questions in the comments, and we will be answering those live.
And don't forget to like and subscribe to the channel if you haven't. So
yeah,
let's get started. What are we going to talk about today?
So this is a very interesting topic. Usually when I start talking about Kafka, I either talking to data people when they building data pipelines, they moving data from one place to another. Say you have some of the changes that happen in the database, you need to capture those and propagate to other systems. For example, you have a hot cache that you need to have heated, so when the things happen in the database.
This is getting complicated.
Oh yes, that's
from get-go.
Yeah, exactly. We're starting with usually Kafka would be used in data pipelines, the type of use case. When there's like data engineers or data streaming engineers building those pipelines. Okay. And a few years back, I would say maybe like 5-6 years ago, when I was at my first run at Confluent, we were start talking about event-driven microservices. So. Data pipelines is good. We're having, getting data from place to place, but also Kafka can be this like a conduit to establish this asynchronous communication between the services. As you said, in many cases, people think Kafka is a messaging system, so why not use this as a backbone for event-driven microservice?
Exactly.
Yeah. So that's what's going to be we're going to be talking today. We're gonna look what kind of challenges and what kind of problems and how we can solve them. And usually, as you know, many problems that might be involved with management of data or data governance or data contracts, usually it's a day two type of scenarios where you didn't realize that you need that, but production is tomorrow. So we're going to talk about those things and how we can solve some of these challenges with the tool called Schema Registry.
Okay. Whenever someone talks about data and integrating different systems, what comes to mind in my head immediately is the different shape of the data.
Yeah. So, let's imagine a situation where we have systems or like microservice. We have two services, like order service, inventory service, analytical service, and everything in the services will talk to the same language. It's written in the same language. It's JVM, Java. We have like a fantastic.
Sounds logical.
Yeah, we have a fantastic technologies to do. Serialization, for example, Java serialization fits very well into this exchanging of the data. So we have this world where everyone and everything speaks Java. We don't need to do anything else. We don't need to worry about anything else except maybe, same version of JVM, same version of bytecode if we're going to be sending Java bytes across the network. And as you can see here, my microservices robots, they speak Java because they sitting there with cups of some hot drinks, as we are as well. And they talking to Kafka. And to be very honest, Kafka really doesn't care about what type of payload you would put there.
So you can put XML, you can put JSON, you can put whatever custom format there is.
I personally would be very much care that you will not pull images or videos inside the Kafka. But you can do whatever, because Kafka only stores bytes. And even though Kafka is written in Java, Kafka doesn't do any deserialization when the message would be produced in the Kafka topic.
So technically, it's just a blob of
Exactly, it's a bytes. So totally fits very well into this architecture. So only these robots, consumers or producers of these messages, they need to know what exactly you're putting there. Now, we exploring the galaxy, and now we finally meet some other artificial or natural intelligence we might incur in our company, not only with Java developers, but maybe with Python developers, maybe Go developers, maybe Node.js developers. So in this particular case, I would assume we do have some sort of very interesting race of developers that fly into this spiky ship. It's probably Python developers that come into our life and they want to do something. And this cool-looking light producing star-like object, it's probably Node.js developers that come into our life. So we need to go into this polyglot world. So essentially, this is going to be the premise of this demo that we're going to be breaking down today. I have a service that is in Java, order service. We can use this as a service that can be used through the API, mobile app, web app to submit orders. We would have some sort of processing done on the Python side of things, and we would have the Node.js dashboard that would be listening this changes. So let's take a look on the premise of this demo. Couple components that we're going to be actively using today. So first component, obviously, we're going to be running with Kafka. Kafka running in Docker Compose in my particular case, but you can run Kafka wherever it's possible. By the way, the code will be also available at the end of this presentation, so you can run all these examples yourself. We're going to be using Schema Registry, which is a web service that runs together with Kafka. And for just simplicity to demonstrate something, I don't want to tie it to any particular tool, but I would use in the open source Kafka UI to just demonstrate what is going on there. Even though IntelliJ has a Kafka plugin, and there's some other offerings available from Confluent, we do have some plugins around Kafka, and that's our premise. And we do have I have three services. One service, order service, written in Java, analytical dashboard written in Node.js, and my inventory service written in Python. So just to make sure that I'm not missing anything, I will just run quickly build. It will pick up, run everything in one shot, and it builds the Node.js application, Java application, and technically it's not Java. I use Kotlin in my Spring Boot application. Yeah,
nice.
Yeah.
It's a Spring Boot application.
Yes, exactly. And will I go with the order service? The haters will say that this demo is scripted. It is exactly what it is. Demo is scripted. It's heavily driven by shell scripts. Next thing we're gonna do.
The folks are asking in the chat if I can share the link to GitHub repository. I guess this is the one that you have shared in our joint chat previously.
Yeah.
I can do that, like Tower of Babel, right?
Babel. Yep, that's
So
you see on your screen.
It goes into YouTube chat. So if you folks want to follow and browse the sources.
Yeah, and also haters will say that it was wipe coded, which I would say it was completely wipe coded. Very true. Wipe coded with Juni with extreme prejudice. We go in with run analytics. Let's run the inventory first. Inventory service, run inventory service. It's running, and run analytics API.
So tell us what happened.
Yes.
Now you started different components from the terminal, right?
Yeah. For now, we do have very simple premise. We do have three services. One service will be receiving the orders. It will be producing this message into Kafka topic. And those two, inventory service and analytics service, will be consuming messages and doing something with this. So for the sake of this presentation, it has a nice UI for analytics service that we're going to be exploring that will basically does some aggregation on the orders, and we will try to see how we collect our revenue from the orders that we just replaced. Now, and as I said in the very beginning, everything starts very simple and everything starts very small because we started with Java. It's a Java service, and Java service needs to pick up the Java serialization format. So we will start with this. We're gonna start with this. To run the demo, I have multiple different examples. We start with, first one is that what's gonna happen if this order service will get this order and publish this in the form of Java serialized object.
Look at this. Viktor is using make commands.
Like old school.
Like old school, like a real developer.
Yeah. So we do have some of the failures, and we can go and observe. First of all, let's take a look how this message would look like inside the Kafka. So my topic here, my orders, and when I look at the messages, it looks something like this. Alexei this morning says, looks like someone just put the hex encoded the values there. Like, what is this? And as you can see here, this is how Java serialized bytes would look if you will get the string representation of this. Mm-hmm. So for obvious reasons, for me, but not obvious reasons maybe for some other people, let me show you. Let's restart this one because it looks like it didn't pick up the topic when it was produced. And when I will run this one more time, this scenario one more time, we will observe some of the errors that would happening on this. It says like, what the hell is this? Like,
so you cannot deserialize.
Absolutely, because it's a Node.js. How are you supposed to know, first of all, like what the class, what do you do with this?
Of course,
right?
Yeah.
Right. So
we need some kind of converter or adapter for.
Yeah. So essentially, when we entering polyglot environment, we have certain number of options that we can do. Obviously, we cannot rely on platform-specific thing. Like, four things come to mind.
XML.
You also showing your age, Anton. I remember the times when the microservices at that time they were called services. We were talking to each other through the SOAP and the XML web services. That was great. And when we go into polyglot environment, you saw how some services will start crushing it. Maybe we have some suggestions in the chat. What kind of format we should use in order to maybe solve this type of problem? It starts with J as well.
JSON problem.
Oh yes, okay. So JSON. Let's try JSON. So in a JSON scenario, we can definitely try to do this. So I do have a scenario that has, say, JSON mismatch scenario, where we're submitting the message that will include something that no one else expecting. So let's take a look what we have in our messages. And we do have, you know what? I just realized that I'm running this in wrong branch. So just give me 1 second. I'll quickly bounce this. And in order to switch this, I do have a specially prepared set of tags when the things are, working. Mm-hmm. in the way how they're supposed to work. I quickly run make build. So that's why it's great to have scripted demos, and Makefile is the fantastic tool. So I realized that in this I do have a broken dependencies. I love Python. It's just like so much joy to deal with Python dependencies. So the Python people talk all the time about Java and saying like how Java is complicated, and Java people talking about how Python is complicated. So let's see if this works, because I know that there's some problems with the Kafka dependency here. So let's rerun this. Make run order service. We're gonna do analytics service again, and we're gonna do inventory service. Now, if I would just run this with JSON mismatch, one of the service will send this order. Order processed. Let's see if our UI was able to bring this in. And yeah, it looks like it's processed this correctly. And the errors that we might have, or was not processed by the inventory service because it expects different format for this JSON.
Right. So if you go to inventory service console right now, we will see some kind of.
So for example, if you don't need to go to console because the service itself can talk to particular API and get the messages in inventory C. There is no messages, even though we see this message arrived successfully on analytical dashboard, but inventory service didn't receive it because it was not able to parse it.
I see.
Here's another error. Like you said, okay, that's not a problem. We can agree about this JSON. We can figure out. Another use case where we have a not only mismatch, but also we do have, there's a inconsistency between sometimes you changing property of
the format is the same, but the schema of this format is different.
I will show you. So, failed create order with invalid amount. So when I submit this to order service, it will not able to parse it in a certain format that it was expecting this to receive. So we see the product ID with dashes, and let's see inventory also did not arrive into inventory service. That's a problem. That's where we see chaos is happening. We need to solve this problem. We need to figure out this madness when every service will decide the format for themselves. Everyone will be, submitting Java objects or whatever serialization is available. JSON is great, but
not so strongly typed.
Exactly.
Stringly typed.
Exactly. Sometimes, remember the times where the biggest selling point for JSON was people saying that, it's a human readable. And
does it have to be?
It doesn't really matter if you have a tooling that allow you to quickly read this. So say I do have I can say that one could argue if this is also human readable. I can read this, understand. Okay, so this looks like this model order might contain amount, which is big decimal. You can see this created that. So you cannot.
Exactly. There is a Unix command strings, and you give it a binary, and it will dump out the strings, whatever you have there.
Yeah, exactly. And interesting enough, there's also see this like SR and some of the bits. It's already not 100% Java serialized. There's some of the nasty bits there that you need to understand how to deal with. And we also can see there's some.
And they might evolve in a different life cycle, right? The formats of different services.
You're absolutely right. This is actually even bigger problem. Especially when we building something greenfield.
Yeah.
Easy. We can see it like few developers, we can agree about something, but when the last time you agree about something, 5 developers, right?
Version 1, new version 1, version final, finally final, and so on.
Yes, exactly. So, and for this, let me start killing the services. So you understand the problem. If you want to retry this, there will be special branch called phase 3, where all these inconsistencies are implemented. You can play around, you can introduce your own problems. So that's for you. And now, we're gonna go in the world of try to bring a little bit hope into this problem.
So is there hope?
Is there hope? But there's hope.
We hope there is.
Yes. My name is Viktor Gamov, and I'm principal developer advocate at a company called Confluent. I'm co-author of the book called Apache Kafka in Action. Kafka in Action, because there's Apache Kafka in Action, Kafka in Action, original one. And I'm here today to bring you from the world of Tower of Babel, from this biblical story where the tower, where the people were trying to reach the God, and they were eventually start speaking different languages. We're trying to bring this to another metaphor, Babel Fish. How many of you actually pick up this metaphor?
The fish that translates any language. Language.
This is fantastic metaphor, and I want to say thanks for folks from the JetBrains who helped me to work on this presentation. Andre and Alexei, we're working on the kind of like what would be catchy thing, and I think that's the perfect metaphor where we coming from the world of crushed Tower of Babel to the world of universal translator. So for those of you who don't know, Babel Fish is actually one of the kind of characters from Hitchhiker's Guide to the Galaxy book. And this is the special creature that will be placed into your ear and will establish universal translation. When I was thinking about this, maybe I should bring the Star Trek references, but I thought this would be even cooler. Now, so we discovering this universal translator. So first of all, we kind of like felt that the native serialization format is not something that we want to have in our application. We want to have something cross-platform, something that would be available across multiple languages. And JSON actually not a bad example. JSON has a lot of capabilities. There is plenty of libraries available in different languages. There's plenty of libraries available even in Java alone or in Kotlin alone. Kotlin language has like native support for JSON serialization and all these type of things. And the JSON is also big standard. But here's the problem with JSON. It's a text base. One could argue that's why it's a problem, because in the world of big data or like a data-intensive applications, having
too much data is moving through the channels.
Exactly, and it's very, you said this. Remember, you said it's kind of self-descriptive, but also it's also a problem because it's a repetitive and it's a redundant. If you have a list of, say, the accounts or orders, how we have it, like 10 orders, you will have a order name, order ID field repeated multiple times. So there's a ways how we can, say, optimize it. I remember times when I was building a microservice again between Java and Python service, and we were sending them requests, and they will send us batch of JSON to kind of like display on UI. And the way how it was done, we use custom JSON format. Essentially, we will say kind of like in the very beginning, we send the number of columns and names of those columns. And the second, we include kind of like a columnar base. Each record will represent like one particular column for one particular field. And after that, on the other side, they were able to kind of like decompose this. So instead of sending this as a list of objects, we introduced,
a very custom thing.
Very custom thing.
Can it be hierarchical? Can you put a table inside a table cell?
Yeah, we were trying to not to, because we were more on an analytical scenario. So we have a table with multiple dimensions. And after that, if we need to do any type of hierarchical data there, we will just like flatten this out. Remember when they were teaching us databases and third number form that redundancy is a bad thing, so you need to have the database tables spread into third normal form. It's actually not entirely true anymore, because in the world of the big data and the web scale type of approach, is better find the ways how this data can be sharded based on certain criteria rather than, so redundancy is not the big problem in this particular case. Now, speaking, the reason why I was talking about this kind of like a beginning of this file, this JSON file that includes the column names and tables. So I think at the time we were onto something, but we didn't realize it at the end. So what about we will have this information that describes our data
along with the data?
Yeah, technically it's called schema, right? So we have again in our XML times. XML times, yes. And we're going to be using the Schema Registry that will be what? Storing schemas. Schema Registry, it's the web service. It's a web service that would be running and give a REST API. And interesting thing about the Schema Registry, so it was designed to be used with Apache Kafka. And interesting, it uses Apache Kafka as a storage.
Okay, so technically, Apache Kafka is a database, right? That holds the descriptions of the data formats, and whenever a message arrives, we can check, you are the message of type boo or foo, whatever. Let's go fetch the schema from this database, and then we know how to work with that.
Exactly. So with this Babel Fish needs to be installed in your ear. So essentially, your client libraries needs to have a little bit understanding what we are, putting there. And
so
yes.
Schema Registry
Yes.
is the Babel Fish.
Yes.
Nice.
The format that we will be talking about, it's called Avro. And maybe it's not the best. Maybe it's not it has like a best compaction of bytes, but it is widely used in the data ecosystem. Avro and Parquet probably it's like two most widely used formats to describe data. And Avro actually checks a lot of things that we talk about. So first of all, there's a way how you can define schema. There's a way how you can generate some of the artifacts from schema, so you will not make any mistakes while translating schema into the artifacts for your language. And most importantly, the schema format is supported in the Schema Registry. And in some literature, in some materials that you can find in internets, these schema files also can be defined as a data contract. Essentially, it's a data contract. We were building our RESTful web services. What do we need to provide them? We need to provide open API spec, which will define the contract. It will define endpoints and the formats we're expecting, right? So why we not use the similar approach, but in this approach, we would use these data contracts that described schema, and they will be stored in Schema Registry.
Maybe at some point you don't have the access to the registry?
We're going to talk about this. It's more like a day 3 scenarios. But to answer your question, Schema Registry supports all sorts of high availability modes to run, and this information will be available. At the end, I will be talking about kind of like...
In the chat, we have some comments like, yes. Isn't it exactly what SOAP did? Yes. Flashbacks from the past.
Yeah, but what exactly SOAP did? So we had description of the web service, and the web service provides us with
envelope.
That will include information about the schema. And it was also up to service that will receive the call to do validation, to check if this schema will be supported by.
And now the service doesn't do that. Now it's validated for the service already.
So this is, we'll talk about this. So the validation will be happening on the client side, even though some of the Kafka implementations, they have ability to do this on the server side. We're going to be focusing only on the client side of things. So remember, like each individual, the service will inject its own kind of portion of this Babel Fish. And I'll show how this would look on the code. The way how we're going to be using in my order service, I guess, event service. This is how my Avro schema would look like. There's a few formats that Avro provides to define the schema. Protobuf, for example, does very similar things, and Protobuf is also supported quite well in Schema Registry. Another option would be use JSON schema. Remember, I was talking about JSON is like a self-descriptive. But hey, even it's self-descriptive, you might need to have a schema. That's like a JSON schema versus SOAP schema. That's more closer comparison. Mm-hmm. Here, it's this still binary format. Would be similar concept, but not one-to-one comparison. Mm-hmm. JSON schema and RESTful service, that would be close comparison to SOAP service and schema definition.
I see.
As you can see here, schema, the word like I said, data contract might include information about types. It does support nesting. You can have composite types. So you can have say field, some status. It can be enum. That will include all possible status. You can also include here documentation. So when you publish this contract, users or consumers of this schema would know what exactly is planned approach to use here. And from the tooling perspective, in JVM world, we are usually not dealing with raw objects. We want to have a typed objects. We want to have a classes. And for this to work in Java specifically, we use an approach with code generation. So we take a schema, we apply a certain tooling that will produce our Java classes. Usually they will land somewhere in generated. And my orders would look something like this.
There is a question in the chat that
Yes.
might or might not fit your demo right now, but maybe we can provide the reference. Can you tell a little bit more about protobuf support in Kafka? So if this fits your demo right now
Yeah.
and doesn't disturb you,
Yeah.
maybe we can cover that.
Yes. So let's do like step back. As a reminder, Kafka really doesn't care what you store in there. Yeah. So protobuf is a format that your consumers and producer will care, and you have ability to use Avro, protobuf, and Schema Registry with serializers that we from the Confluent we provide this. Those source available, you can use it for free. There's no any license applied there. So if you have Schema Registry, also source available, freely available part of the source of the software. But there's very important but. Remember, I showed you this strange looking object. Starts with blah 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 SR.
So there are some control byte sequence.
Since I use a mystical slides for my presentation, let's call it magical byte. And this is how I should actually call it in documentation. Essentially, when you were talking about the architecture, you actually guessed a lot of these things. So inside this serialized object, we have some pointer that would say that this object was encoded with the schema blah version blah. Mm-hmm. And when the client will receive it, client will read these bytes, first bytes, and say, oh, I see, looks like it uses schema blah in version 2. So what it will do, this deserializer Java class will go to Schema Registry, get the definition of schema, apply, and Avro framework will provide the tools to deserialize. Absolutely the same approach works for protobuf. You just need to use different type of serializer. Absolutely same approach works for JSON schema. And more importantly, it works with any existing tools. There's a Maven plugin that generates Java POJOs from JSON schema, and there's a Gradle plugin that generates Java POJOs from JSON schema. It also works in the conjunction with the Confluent Schema Registry deserializer. So everything except certain parts in terms of capabilities and the backward and forward compatibilities that might be different between formats, but this is very well described in documentation. If you will be looking to Schema Registry documentation, you find different levels. I'm going to be stuck to Avro because it's something that I got very used to, and I know about tooling, so I can talk more about this. But in the past, I did a lot of demos with protobuf.
The trick with magic bytes reminds me of something of the magic bytes inside Java classes. If you remember, folks, what the magic bytes are in Java classes, type in the chat.
Type in the chat.
I wanna see if all of you know what it is. What it was.
Interesting thing. So this order, it looks like a POJO, but also it extends some of the framework classes. In this particular case, specific record base, and also specific record, meaning that Avro can be generic you can define the object without creating an actual Java Pojo class, and you can go and create this object and get access to individual field by calling individual method. But since we're interested in Java Pojo because we want to use this and expose this thing into Java service, we are using this specific Avro record. And as you can see here, we have definition in schema also baked in inside here, but also most importantly, what we do have builder to create the object. So we can, using the builder approach to, instead of like having the constructor with the multiple fields, builder already auto-generated. And also it is generated a serializers and deserializers. So essentially what the Kafka serializer, deserializer would do, it would just delegate the calls to methods like from bytes, from bytes to bytes, and all this kind of thing. So this class will be self-contained. It will include only important information that will be sent with this into Kafka topic. Mm-hmm. Schema will be stored in the schema registry, and your Java class would be stored in your Java class path. Okay.
Sounds logical.
Yeah. So in the same approach, we go with other languages. There's tools to do code generation for Python and Node.js, and that's why it does as well. So we use one common schema for those objects. So now let's see how our services will communicate. So let me make sure that I am running is correct. I'm still in a different version. Let's go into phase 5 complete, and we do how we can ignore this. So we'll just do git discard. Where's the
command option Z?
Command option Z. Oh, nice. So, and we're gonna go switch into the phase 5, and traditionally I want to run make build just to make sure that everything would be tip top. So what is happening? It's pick up the dependencies and also generates some of the code. Each individual microservice includes its own code generation logic. So let's take a look. For example, here there is a scripts and generate classes. Based on location of the schemas. In this case, it picks up from directory schemas version 1. It will take the schema from here and generates services, inventory service, SRC generated. So that's how our object would look like inside a Python application.
Do we have a version there?
No.
No.
Because this is irrelevant. This information would be stored
inside the serialized object,
yeah.
Right? So there was a question about different versions and how this would be handled.
I will show you. I anticipate this question, so that's why I came prepared. Now we do make order service. We make analytics API. And we will kill this guy. And what it says? Schema Registry good. We'll see. Maybe there's some leftovers in the Kafka topic, and it was inventory service. Now, with this demo, I do have make phase test. And we will be submitting now messages in the format that we expect. Failed. Interesting. Python. Let's see if the Python version picked up correct version of library, because usually this happened with Python could not pick up the version of Kafka client that knows how to work with Schema Registry. So let's quickly rebuild this. But meanwhile, I can go and check the analytic dashboards. We'll start this new new order arrived here, so all good here. And if I run this, inventory service is not running. I would just make inventory service. Inventory service, not the smoke test. Inventory service. No, run inventory service. Okay, and let's run this one more time. So different scenarios will perform different operations with the schema registry. It's time to take a look inside. Still failed. I don't know why, but let's see if it messages actually in inventory. It's not there. Interesting. I need to investigate this later, but let's move on still. Inside our topics, we have orders. And now we also would see, you see, it's readable. And the reason for that, it's not about having human readable things. You need to have tools that allow you to read this data. So for example, this particular case, this Kafka UI knows how to go read this magic byte, go to schema registry, and find this orders value. In the world of schema registry, we call it a subject. The subject will define how the data would be stored in schema registry and how this will be mapped into particular things inside the Kafka. So in this particular case, as you can see this, it's the topic name dash value. In Kafka, we do have two things. We have a key for message, and we have a value for message, and we have some additional metadata. But as a user, as a developer, you can use like a key and value to define different types. So in this particular case, we saying that we are interested only in storing value for our data. We don't care about the key. And that's why inside my orders, I can say that this key would be string, and value is a schema registry. So if I will go deeper here, I can see schema, and it says, oh, backward compatible. Wow, what is that? So we're going to talk about this.
Nice.
So Avro is a data contract. We define a schema. We're using tools to generate source code based on the tools. In some languages, you can use dynamic thing. I prefer code generation because I'm a more like a SDK type of person. I would love to have, the instead of giving me open API spec, I would expect you to give me SDK. And the same here. If I would want to use schemas, I would create some sort of version that would be stored as a versioned Java file inside my Artifactory or Maven Central.
So in my case, since I don't know the internals, I'm kind of playing this investigation and trying to guess where are we going to get next. So the version is encoded in the generated serializer, I guess.
Magic byte will define the version.
I see. Okay, nice. But it's added by the serializer.
Yes. And this is a very good question. This is a very good point, because if you will be looking examples on the internet and you will be looking examples for Avro, Kafka clients and Kafka producer and consumer already ships with Avro serializer. But this is not Avro serializer for schema registry, because if you would serialize this Avro format, you only will be able to read this if you have this schema handy. So say we have this file and Kafka console consumer that understand how to connect to schema registry, Avro console consumer, you need to specify this Avro schema yourself. When you will be using the schema registry will be retrieved from the schema will be retrieved from schema registry.
We mentioned the backwards compatibility, and there is a question in the chat that probably leads us to this topic.
Yes.
I
love our listeners. You're anticipating our every move.
Nice. So they noticed that the Schema Registry has a global compatibility level, which is backwards, forward, full, etc. And is that a server-side feature to manage the schema updates?
Yeah, we were going to talk about this. Yeah, so essentially it's a feature of the schema registry when you will be, say, you see this gentleman here registering schema in the Schema Registry, and essentially it's a web service, and you're using like a REST API to talk to the service in order to register your schema. When you're registering schema, you will be specifying the level of compatibility that it will be applied to schema that was stored inside another topic. And one of the things that we just saw, we can see. Let me run example of I have a make evolution just to demonstrate, and we're going to come back to this compatibility mode. So I do have script that will runs a few scenarios. First scenario would be is to register new schema inside the Schema Registry. That's not supposed to happen because it should use correct the format, like the order name, the topic name, and value. So in this case, it is using like incorrect storage. Also, you can ask certain things about the schema compatibilities when you're submitting. And also, when you try to submit incompatible version, you will get a rejection, and it will give you like what's the type mismatch here between different.
Incompatible meaning there is no schema in the.
It means that
registry.
When you try to evolve the schema to the next version, adding more fields or modifying fields, you break in some sort of contract that you're not supposed to see. And this is something that you need to define when you define the schemas, because it is. There's certain rules that you define at the very beginning. So backward compatible, meaning that your future consumers will be able to read your
Old messages.
And forward compatible, it's vice versa. No, like future forward compatible, when your future consumers that understand schema 1, they also understand schema 2. Schema 2, they also understand previous version of the schema 2.
Okay.
When we have a schema version 1, I'll show you. It would be better to understand in example. So remember when I was using my order service, I was generating this order class from schema. So let's grab the version of the schema that has new version. We're getting additional fields. This is very interesting because this is kind of like a life experiment that should not break. That's the whole point. So in this case, we can see diff that we added 2 more fields here. Let's do this one. A few more fields that is will include some additional metadata, some additional timestamps, and blah blah blah. Now remember, I changed it only in the Java service, so I will go and restart. Yeah, I'll just do make run order service, run the build one more time. So it will generate new class for my Avro order. So essentially, my code doesn't use this new fields for now. So they should land as a fields. But since we specified them as, it can be null as a value, they will be including metadata equals null. That's the goal. So in this case, if I run this, submit the message. If I'm gonna go in my topics orders in one of the recent orders that I submit here, it should include information based on the new schema. In the Schema Registry, for the same object, now we have multiple versions. See? So actual version is version 4 and says it's backward compatible, meaning that old consumers will be able to read this data as well. And there's some other versions of this data. So my analytical dashboard should be able to consume this message, and we produce message with something is wrong with my Python code, which is maybe serendipitous that I should not touch this pesky the Python code. So this is order information that was produced with new version of Schema. It was successfully consumed by analytical dashboard application, even though we didn't know anything or we didn't do anything explicit to deal with the schema. Some of the clients that would be connecting to Schema Registry and will be showing some of the information, because they were able to pull this schema out of Schema Registry, they might actually render this the value from Kafka topic that will include these fields with null values. But in this particular case, it doesn't. It doesn't do that, but even though it uses the version of the schema that is evolved, that came from the different generation. Now, this is kind of like one of the subjects that I also expected people will ask questions. So one of the questions that I usually get asked from the people is, when perform this generation? Is it part of the build or is it part of CI/CD? Do you share schemas enough that everyone will generate their own stuff? Do you share SDKs like jars and things like that? So, and there's always answers. Mm-hmm. An answer always depends, right? It depends on cultural aspect. Some of the languages might not require compile time dependencies. In Python, we generate those objects just for, to keep our code readable, so we know what kind of objects we're reading or writing to and things like that. Same thing with JavaScript, like dynamic language. For languages like Java and Kotlin, we need to have those things at the compile time. Mm-hmm. So treat this as SDKs. Treat this the way how you treat your open API specs. If you have this centralized place where the people can read these data contracts, in this particular case, Schema Registry, there's some like additional plugins available for developer portals like Backstage and things like that allow you to kind of have a unified view for your open API and your event-driven kind of async API approaches. There's tools that allow you to build into your CI/CD. Say, for example, in one of the demos that I did a while back is I use GitHub Actions pipeline that would go into approval process. Mm-hmm. Someone submit update to schema in the form of PR. We have all responsible people who needs to approve this, and it will not trigger build of this new version of SDK until people will approve it. There's enough discussion happened. They would say, yeah, okay, merge this PR, and after that it will perform Gradle, generate Java Avro, get the Java files, send them to Artifactory or Maven Central, and tell other people, if you want to use the version 2 of these schemas, please update your jars. And in this case, in their applications, it also would be a record that they updated. So it's not like it dynamically went and changed application code. You don't want to do that.
So you generate kind of an extra dependency out of the project to be used as a dependency.
It's one of the approach when you have this kind of like a GitOps style pipeline talking about the and also you can even register those things directly to Schema Registry. Remember when I said some languages will not require you to have these artifacts. Like in Python, you can easily, if you want to get another version, you just go there and say, okay, I will fetching the latest and greatest version, mm-hmm. and I will be using this. Dynamically will parse it. So the two approach with this, if you SDK type of person, or if you kind of like centralized developer portal type of person.
Well, if we touched CI/CD part, inevitably we get to touch testing. So there was a question in the chat: is there any tool that they can use to test simulating Kafka? But why simulate? We have
Testcontainers.
We have better tools like Testcontainers.
Yes. So one of the things that you can use Testcontainers. If you're not using Testcontainers with Kafka, you are missing out big time. And the cool thing about Testcontainers support a few flavors of Kafka. It supports open source images from Kafka. It supports images from Confluent. It even supports some of the alternative implementations of Kafka protocol. And it does support Zookeeper, not Zookeeper. There's no Schema Registry built in, but in some of my examples, I have Schema Registry test that it's just a simple stateless web service. Generic container will do. Generic container, expose map ports, and you're good to go. Mm-hmm. In my demo, if you want to go and check it out, how you can configure those containers, you can find a Docker compose that says what kind of Schema Registry parameters are important to configure. Another thing that I didn't show, but Anton also touched about this, if I would enable internal topics, you will see this topic called schemas. So this is how the schema stored inside Kafka. Mm-hmm. Schema Registry, it's a stateless, it doesn't do anything, doesn't need any database. Schema Registry dealing with Kafka, and all the data lives in Kafka. So as you can see here, there's a...
So does it mean that Schema Registry is actually a topic?
Schema Registry, it's the if we're going to be talking about the Kafka terms, it materializes internal schema topic and it presents this as a table. So it is one of the ultimate representation of stream to table duality. When the Schema Registry will start, it rehydrates internal state about schemas, about schema versions from the topic from the Kafka. And this is, I think that's the fantastic tool that Kafka internally uses Kafka a little bit. That's why you have this consumer offsets the topic to maintain state of clients. But also other services would use Kafka to storage. And we didn't even talk about Kafka streams, which Kafka streams also heavily use Kafka for internal storage.
I see.
As you can see here, each individual value will include version of the schema, subject, and that will include orders and values. And you will see if that's kind of like marker, because when data comes into Kafka, it's not disappear until it will be expired. But what you can send in another message and says deleted. So this is how you hide this from the schema would be retrieved. So with this CI/CD, it's also possible breaking changes. Breaking changes happened. There are situations where you need to break the change. So in this case, it's a big event. You need to communicate.
Will you try breaking stuff right now?
I do have a scenario that introduce a breaking change. In my scenario, when I run, say, make demo evolution, when I try to evolve and produce different versions of the schemas, I do have example of breaking schema. And the difference between schema that I have in my...
So I think it would be great to show what happens and then how to troubleshoot that.
Yeah, exactly. That's what I'm showing you. So when you try to register the incompatible schema, you will get the response from Schema Registry saying that, hey, there's something wrong. You're trying to have a schema for the same subject. So we assume that it's going to be a new version, but it includes something that never was introduced before. So in this particular case, we have an order event and order event. And if we will take a look, what's the difference? In this case, we're using this different order of this. We introduced like user ID, and we changed something else, like we removed some of the fields. So it is broken. So it will not be able to register this schema. So all the things would be rejected. as already was said, there's 3 compatibilities mode, backward and forward, meaning that it's all about how your previous producers will be able to produce data in old format, and the consumers in the new version of consumers will be consuming it as forward compatibility. Backward compatibility, where your new producers will produce messages in new format, but your old consumers will be able to consume in the old format. And full compatibility, so you can move in future in the back and forth. So those modes you need to be, when you're designing schema and you're communicating this design of schemas between your I have this slide for this, between your services, everyone now have like understanding there would be no inconsistencies, because these things would be resolved during the planning and deployment phase.
Great stuff. Well, we are running out of time, and great stuff, Viktor. It was a cool demo, and